Hi, my name is Mitchell O'Donnell and today I will be taking you through the theorem of superposition and showing you a step-by-step guide on solving an example problem. The theorem of superposition states the current through or voltage across any element of a network is equal to the algebraic sum of the currents or voltages produced independently by each source. The steps to solve a superposition problem are as follows. Number 1. Select a source. Number 2. Remove all other sources by replacing the voltage sources with short circuits, keeping any internal resistance, and replacing any current sources with open circuits, also keeping any internal resistances. Step 3 is to determine the voltages and currents arising as a result of the selected source. Step 4 is to repeat this procedure for all other sources. Step 5 is the final step and is to add all the resulting voltages and currents arising from each source. Also note to keep in mind to observe the polarities of the individual voltages and directions of the individual currents. We are now going to take a look at an example problem and use the steps that were previously stated to solve the problem. This is a basic superposition problem that will further your understanding. The example requires us to find the current flowing through I2. The second step is to replace any other sources with the appropriate method. This case, an open circuit, as we are replacing a current source. The next step is to determine the current that arises as a result of the selected source. This is simply the effect that the 36 voltage source has on I2. To do this, we take I-2 is equal to the source voltage, E, divided by the total resistance, which is R1 plus R2. This gives us 36 volts divided by 18 ohms, which is equivalent to 2 amps. Now we are going to repeat these steps with the current source, this time replacing the voltage source with a short circuit. The result is a parallel combination of resistors R1 and R2. Applying the current divider rule results in I-2 is equal to R1 times the current from the source, which is 9 amps, all over the sum of the resistors. This gives us a total current of 6 amps. We can then move on to step 5, having replaced both sources and determine the currents that arise due to the sources. The resultant current I2 is equal to I-2 plus I-2. This is 2 amps plus the 6 amps, which gives us a total of 8 amps flowing through the 6 ohm resistor. That is all for this video. I hope you enjoyed and found this helpful.